Welcome to Session 4 of this week in Environmental Law and Policy. As promised, I dress up because mostly today we're going to talk about theory. And we're going to talk about a theory of property that wasn't really caught in any of the cases we looked at in the other sessions this week. In each of the earlier sessions, the property at issue was private property. And there was a complaint from private property owners that the government was going too far in its regulation of their property. And yet, in a lot of environmental disputes, there's another type of property, common property, or more frequently known as the commons. This can include things that we're totally familiar with, like the atmosphere or the oceans, especially the high seas that no country claims, or things like wildlife that nobody owns. Commons are owned by no one, or put another way, maybe owned by everyone. And a legal regime that governs them is of particular interest in environmental law. But here's the rub. Under the most common economic theory of the commons, rational people, even when they want to, find themselves unable to effectively govern the commons. This model, which is more frequently known as the tragedy of the commons in environmental disputes, after a very famous essay published by ecologist Garrett Hardin in 1968 in the journal Science, is central in understanding legal regimes governing common property resources. And to introduce us to the commons, I'm going to use the work of one of my favorite political economists, Elinor Ostrom, who in 2009 was awarded the Nobel Prize in Economics for her work on commons management. The interesting thing about Elinor Ostrom is not only does she describe very well the standard approach to the tragedy of the commons, but she also adds and weighs in on possible solutions. So we're going to use Elinor Ostrom's work both to understand the tragedy of the commons and to see its standard solution, as well as some other solutions that the law might be able to deliver. I do want to start with the work of Adam Smith. It's a pretty good starting point because Adam Smith is viewed as the founder of modern economics. And in The Wealth of Nations, he had this very famous insight into how economies work, or at least it was a famous claim, and it was this: if we just trust every person to use the resources at their control in the way they think best, just following their self-interest, without any prompting by the state or anyone else, the public interest will emerge as if by an invisible hand. No need, in other words, for the government to figure out what the public interest is. The market will deliver it. The interesting thing about the tragedy of the commons is it suggests that that doesn't happen when we're dealing with common property regimes. Instead of getting the best of all possible worlds by the invisible hand, the tragedy of the commons suggests that the world is going to get the back of everybody's hand. And there's some empirical evidence to suggest that commons are in trouble worldwide. So it's not just a theoretical insight, there's plenty of empirical evidence to suggest it's true. Let's see how the tragedy of the commons models how people might behave when they deal with a common property resource. Elinor Ostrom uses a very simple society. The story that goes with this is something like this. Imagine that there's a small society of just two herders who make their living by herding goats, raising goats for the market. And they turn their goats out to pasture every summer in a pasture owned by everyone or owned by no one. It's a common open access commons in this two-person society. There's herder A and there's herder B. Now they know this. They know that if they put out too many goats, the goats will overgraze the commons, cause the commons to die, just collapse, maybe not just that year, but forever, in which case they're all in the worst possible situation. That is to say, I'm giving them full knowledge of the consequences of what could happen if they turn out too many goats. They know this. They also want to make money. That's their self-interest. They have full information and they're acting rationally. Well, two people, even in the absence of the state, could get together and come to an agreement. They could, for example, ask themselves, well, what's the carrying capacity of our commons, of our grasslands? How many goats can be put out? And sustainably use the commons, meaning use it, but do it well within its regenerative possibilities. Use it sustainably. Let's say that number is C for carrying capacity. Well, an obvious dividing point is to say we'll each put out half that number, so that together our goats add up to C. So they make an agreement. Each of us will put out C over 2 number of goats. That's their agreement. And if they cooperate with that agreement, and each does that, well then, the commons will give them a very possible and very strong return. So in this chart, in the upper left quadrant, I have modeled what happens when herder A and herder B cooperate on the C over 2 formula. Each will get a payoff of 10 units. It could be dollars, it could be drachmas, it could be anything. 10 units. And assume that's a good number. The first number, by the way, is the payoff to herder A. The second number, also 10, is the payoff to herder B. And that's what happens when they cooperate. What happens if they fail to cooperate? And by that I mean they don't reach an agreement at all, or they do reach an agreement, but one or more of them secretly cheat, which means they don't really make an agreement. When that happens, the term we'll use is defect. Instead of cooperating, they defect from a cooperative outcome. And if they both defect, I have suggested what I did earlier. The commons will collapse and the payoff to each of them will be 0. Assume that's true. And more importantly, assume they know it. Well, rational thinkers at this point would say, if this is what is known to them, which would they prefer, 10 or 0? Well, that's easy. They prefer 10. And so, just acting out of self-interest, they should cooperate. Here's the insight from the tragedy of the commons. Herder A doesn't know entirely what herder B is going to do. Herder B might cooperate, in which case, if I, herder A, cooperate, I'll get 10. But what if herder A does cooperate and I cheat? I put out a few more goats. Although there'll be more goats than the environment can sustain, I'll make it up in volume. My goats might be a little thinner, but I'll have more of them, and I'll be better off. I have marked that possibility with the payoff of 11, which is more than 10. Let's assume that if herder A defects, he or she can assume a payoff of 11. What's more, in that situation where one side is cheating and the other side is holding to the agreement, herder B becomes what's known in economics as the sucker. And the sucker payoffs I have illustrated with -1. That is to say, the goats belonging to herder B are so thin because there's so many goats out there, and they don't make it, he doesn't make it up in numbers, that herder B actually loses money. Maybe because after they come back from pasture, herder B has to spend more money to fatten them up. Assume that's a good number though, the sucker's payoff. Up in the upper right quadrant is just the converse. What happens if herder A cooperates, the sucker, but herder B defects? And I made the payoffs accordingly. Once we appreciate that each of these cells reflects a plausible scenario, the rest happens unerringly and logically and tragically. Let's see how this works. Herder A isn't entirely sure what herder B is going to do. If herder B cooperates and I cooperate, thinks herder A, and we both cooperate, I'll get 10. However, if herder B is going to cooperate and I defect, I get 11. What's my best play following pure self-interest? Cheat. 11 is better than 10. Well, what if on the other hand, herder B in fact defects? If I cooperate, I'll get the sucker's payoff. I'd be terribly worse off. What if I defect? Well, if I defect, I would get 0. Well, let me tell you, 0 isn't good, but it's better than -1. So my best play, if in fact I think herder B is going to defect, is also to defect. The result is, logically, following pure self-interest, herder A will defect. And using the exact same logic, so will Herder B. They both will defect, getting payoffs of 0. And what that reflects is that the commons has collapsed, even though they went into it with self-interest and full knowledge of a way to fix it. This is not what Adam Smith predicted. This is not the invisible hand giving us the best of all possible worlds. It's giving us the worst of all possible worlds, the back of the invisible hand. Here's the standard solution. The standard solution is to posit the state. And Elinor Ostrom calls the state Leviathan, after Thomas Hobbes, the political philosopher. Let's assume a state that can detect defectors, those who cheat, and is never wrong. And every time the state finds a defector, they impose a punishment of -2, unerringly. And let's assume a perfect Leviathan. Now, introducing this solution into the commons grid that we established, look what happens. Herder A and Herder B, if they both cooperate, each get 10 as before. Nothing happens and the state doesn't do anything because there's no defecting. Everybody's cooperating. If, on the other hand, they both defect, this lower right quadrant, the state sees it and imposes on each of them a penalty of -2. That's their payoffs. Now look at the southwest and northeast quadrants. Those are the interesting ones. If Herder A defects before, Herder A got a payoff of 11. That was the cheater's bonus. But now there's a -2 penalty imposed on Herder A for cheating. So 11 minus 2 makes the payoff 9. Herder B's payoff of -1 doesn't change because Herder B was cooperating, was the sucker. Look up at the northeast quadrant. This time it's reversed. Herder A, which was the sucker, continues to get -1, but Herder B, the cheater, instead of getting 11, gets 9. Once we establish the state and assume it acts the way it did, look what happens now. Herder A still doesn't know what Herder B is going to do. But if Herder B cooperates and Herder A cooperates, there's 10. If Herder B cooperates and Herder A defects, there's 9. Which is better? 10. 10 is more than 9. And so a rational person, now operating in the shadow of both the market and the state, will choose to cooperate. If Herder A thinks that Herder B is going to defect, you get a similar dynamic. On the one hand, if I cooperate, it's true, I'll get the sucker's payoff -1, which isn't good. On the other hand, if I defect, I would get -2, which is worse. The result is -1 is still better than -2. My best play, even when Herder B might defect, is to cooperate. Both options lead me to cooperate, and therefore, with the introduction of the Leviathan, both parties are incentivized to move up to that happy northwest quadrant where each gets the maximum benefit, and the commons is preserved sustainably. That's the standard solution. There are other solutions, by the way, that I'll just mention briefly now. Here's the first, which is get rid of common property. Privatize it so that every owner of every little bit of the commons is motivated by self-interest to preserve the property. You don't have a commons dynamic. That might be good in some respects, but in other respects, it's highly problematic. How, for example, are we going to apportion the air to individuals? There's obvious problems if the air belongs to somebody else. Or, a fourth possibility. Elinor Ostrom, in fact, chronicled this. She discovered that many societies around the world and over time, in fact, have commons that they've managed effectively. Put another way, it didn't collapse. And it didn't collapse even in the absence of a strong state, of a Leviathan. She found that under some circumstances, shared norms of value can lead to sustainable commons. We'll come back to some of these options later, but for now, here is a big insight. If you want to know what environmental law is in general and worldwide, the standard solution adopted certainly in the United States and in Western Europe and in Japan and in many of the world's developed economies is Leviathan. We have created powerful statutes and empowered powerful bureaucracies to seek out defectors and impose penalties to induce everybody to get the overall commons that we need. That's enough for today. Next time, we'll see where property rights meets environmental protection at one of the front lines on environmental disputes, the protection of endangered species and its collision with property rights and property right owners. I'll see you then.